Okay, so today term starts. We have lectures going on today for the first time, so it is officially week 1 of my first term. I think I'm going to butcher the name of it. I think they call it Michaelmas. So yeah, you have Michaelmas, Hilary, which is term 2, and then you have Trinity, which is term 3. I mean, personally for myself, 1, 2, and 3 seems to work absolutely fine. And giving these really fancy, weird names just is a bit more than I really like to operate at. So I'm just going to stick to term 1, term 2, term 3, right? So essentially, for my course, it is a master's course. It was really nice. The reason I picked this course was because I don't need to do a dissertation unless I want to. Some people are, credit to them. That is not the game I would like to be playing this year. 2, there's no core modules. So essentially, every single module I get to pick this year, I don't have to be told this one you must do because it is essential, right? So essentially we have all these freedom of choices to go and pick any modules that we want, and you have all the different paths that you can go down. So for those that don't know, I'm doing mathematical and theoretical physics. Nice little mouthful there, always good fun. That sounded extremely suspect, but yeah, I'm not going to clip it because that's more editing time. So I am doing the route of strings and particles. There are other routes that you can do on this course, such as astrophysics, plasma physics. So plasma would constitute this idea of nuclear fusion, which, you know, is a pretty big thing that we are looking at to try and use as a form of energy, because coal and oils and all this good jazz that has been very, very helpful to us as a human species will go at one point, but I can't give a number. I think 100 years, someone was saying, but you know, I'm going to be long gone before then. But it's to some extent our responsibility to try and help out for the future. You also have the route of condensed matter, which deals with quantum systems on larger scales and everything. So if you look at like solids, you can then break it down at each individual lattice point and then kind of expand that using some quantum mechanics. Very, very basic. It's a very complex field, but deals with more, how would you say, more than just one kind of particle. It deals with this multi-magnitude, multi-body kind of system, right? You also have other routes such as fluid dynamics, and some people very much would just care to go down a route of absolute pure maths for fundamental physics and everything. Me, I'm doing quantum fields, strings, and particles, like I said. So my modules for this term, I have picked quantum field theory, groups and representations, general relativity, and currently I probably will drop it because I don't want to have to take on too much work each term. I kind of want to split it out quite evenly. I've taken on differential geometry manifolds as a nice little thing that they basically sum it down to, right? So what each module is quantum fields. This is this idea that in the grand scheme of things in physics, you have 4 fundamental forces. People know gravity. There's electromagnetism, which is, you know, when you take your 2 magnets, they repel, they attract, or when you start getting static electricity, that would be a form of electromagnetism. It's all really good stuff. Electromagnetism, you actually find, is also somewhat the reason that you can't really fall through your chair, with quantum mechanics involved and Fermi-Dirac statistics and stuff that is, I mean, far beyond my head and everything. I just know that it's a cause of that, right? So you also have the strong force, which holds the nucleus together, because if you guys actually think about it for a second, you'll take your protons and your neutrons. Neutrons have no charge, protons have a positive charge, and with our electromagnetism, we know that these protons should just be trying to repel each other. But for some reason, in the nucleus, they are held together, and you have to kind of go, wait a minute, why is that happening? So there's this other fundamental force called the strong force, which acts on these certain particles called baryons, I think they're called. So yeah, hadrons, that's the one, hadrons, and it holds these things together, and it only works at a very short distance, so it works in the nucleus. Then you have the weak force, and guys, I'm not even going to try and explain it. All I know is that it operates through like weak decays. So you have all these decays of like particles changing to different other particles and everything, and that happens via the weak force, right? So quantum field theory essentially takes the electromagnetic, the strong force, and the weak force, unifies them all, and brings quantum mechanics into this like pretty unified theory, right? The only issue is that gravity is missing, and that will play a later role in what I explain. But essentially, all of those work together, and it's one of the most, if not the most consistent theory in all of physics up to this point. I think certain tests have compared theoretical expectations versus actual experimental results up to 11 decimal places, which is just, I mean, pretty absurd. I don't even think you need to be a mathematician or physicist or any person that knows numbers to any level to go, yeah, fair play, that's pretty decent, right? So that's that module. It's a foundational module for any theoretical physicist that wants to deal with any form of quantum mechanics, and it's the module I look most forward to this term by a fair long shot, I think. And then you have groups and representations. This is kind of a more abstract module. It gives you the tools that you need. So you have group theory, representation theory, and in the most simplest way, it's just talking about, you know, if I rotate things, are there any symmetries? If I flip things, are there more symmetries? Representations bring in this idea of matrices and everything, and you find that links very nicely to quantum mechanics, where you have these things called the Pauli matrices, which deal with spins. And don't worry about all this stuff. I say don't worry because I can't explain it, because me myself, I don't actually really know it very well. And then you have general relativity. So for those that are probably not, or maybe not familiar with it, it's a pretty well-known thing. So Einstein's theory of general relativity deals with this idea of space-time. So back in the day, I think it was like in the 1500s, Newton was cracking about and just said, hey, I'm just going to solve this whole gravity thing, like how the Earth and the Moon orbit and this, that, the other. And he said it's related to this 1/r² relation with some constants, and it just depends on the masses. Cool. Seemed to check out very nicely. Einstein then said, wait a minute, Mercury doesn't seem to obey the calculations quite perfectly, and he decided, hey, you know what, Newton, greatest physicist of all time, yeah, that Don doesn't really know exactly. He had a good idea, but I'm gonna, you know, clear up his mistakes, you know, fill out the cracks and everything. And he used some very, very advanced level maths, which is differential geometry, tensor calculus, which I actually do not know. I won't even try to explain it because I am only learning about it this term. And essentially talks about this idea that mass, if it's here, take your table, you put your mass down, it would kind of bend this table, and light kind of curves, like follows these curved paths and everything. So yeah, very, very interesting. I really look forward to that. I think as a physicist, I think if you really want to understand theoretical physics, doing general relativity is like, maybe not prerequisite for all of it, but it's definitely a cool one that you should do if you spend all this time doing physics and maths, right? Then you have differential manifolds, which sorry, that lorry was getting a bit binned on. He was getting a bit loud for me. So then you have differential geometry, or manifolds, more typically known as, which encompasses this whole idea of what Einstein used to basically define general relativity. This is just the pure maths module version of that. I'm going to do it because I think it makes the other two of the other modules, the groups and representations, because we deal with manifolds in that when we look at these things called Lie algebras and Lie groups. Cool. Once again, not explaining it, I don't know it. And you also have obviously all of general relativity is just manifolds. So I think it'll be a nice one to add in just because it doesn't feel like I'm taking on more workload and everything. So those are the modules I'm going to do this term. I can't go into too much depth as to what they entail because obviously I haven't learned them, but I really look forward to them. I think this is finally now a point where all the stuff that I was always interested in physics, I can finally start learning. So now it's the time to actually just crack on and start doing that. I have my first lecture's at 2 o'clock today, and then I think I have another one at 3, and then one at 4. So 3 straight hours of lectures. Maybe not exactly the way I'd like to go for the first day and everything. So, hey, but we play it by ear. Some of them on the physics building because those are primarily more physics modules, and then some are in the maths building because those are more just quite pure straight maths modules and everything. So I'm gonna have to walk in between those and everything, but it means that I can just show you guys how nice these buildings look and everything. So we look forward to it and we crack on. It's just insane.
Okay, good afternoon everybody. 0.00159218.076. Okay. And the error is 28 in the last 2 digits. If you're not impressed by this number, you should be. This is an amazingly accurate measurement. In theory, which basically means QED plus a few bits, quantum electrodynamics tells you that this is 0.0011 596 5218 1643, and the error is 7. So the error basically comes from the bits you don't know how to calculate.
Right, okay, so just finished QFT. That was kind of wicked. I really enjoyed it. The lecturer was named John Wheater. I remember watching some of his pre-recorded ones because there was a couple of stuff that you had to cover if you wanted to just make sure you were up to date and everything, because he taught a module that was at Oxford last year called Advanced Quantum Theory, I think it was, or something like that. Advanced Quantum Mechanics, that's the one. But right now I have a little break in between this and GR, so I'm whipping up some food. A lot of goddamn chicken. It's almost, you know, there's a philosophical question that needs to be asked of was the amount of chicken that I've had to consume in my entire life really worth, like, trying to get as big as, you know, trying to put as much size on as possible? It's a genuine thing. I reckon I've probably gone through around, yeah, I think a clean 2,000 chickens have definitely lost their lives for me to get to the size I am now. So, will I stop? Definitely not. Sorry for the vegans and the vegetarians and all those people, pescatarians as well. You guys have a little good gig going on yourself. But me personally, no, not going to stop. I just like meat. Once again with the suspect chat. A little bit about, ooh, Reggie, what do you say? But yeah, so I was meant to have groups and reps, but they've kind of absolutely confuzzled that timetable. I think the person that's meant to do the timetabling had a little bit of a seizure or something, because weeks 1 to 7, Tuesdays, Thursdays, completely fine. But then weeks 3, 4, and 5, we have Monday lectures as well. as all the other Tuesday, Thursdays. And then in week 2, so next week, we have a double on a Friday, and then never again. And then none in week 8. So, I mean, they were kind of thinking, oh yeah, 8 weeks is long enough. I don't know, but I'm probably going to unintentionally miss a couple of those lectures just because it seems like a bit of a brain mess up. I'm going to try and do my best, but you know, is what it is. So I'm going to try and get this down. Granted, I think I have like 20-ish minutes. It's like a 5-10 minute walk to the maths building, so I'll record that. Not the walk, because that's just long, and I'm not going to carry my phone and just walk on a public path, because there's some level of dignity that I want to have when I'm recording. So yeah, but we'll see how that goes, and should be alright.
There's also a problem sheet 1 which has a few questions, special relativity as well, which is example of.
Okay, time to close up shop. Right guys, so essentially first 2 days are done now actually. So yesterday was the first day. That's all the stuff that you're going to see in the video. This right now, this is the second day, this is the end of that. So I've had every single module, like a lecture for each one at least, except for the manifolds module. That is tomorrow. I look forward to trying that. Still, once again, it's pure maths. That is just an absolute fight against Mike Tyson, in my opinion. I'm just not going to win it. But maybe that's me saying the wrong mindset for the case. Maybe I can just do it. I'm sure I can. Okay, Alex. But yeah, basically, I'm going to go and give that a crack. I look forward to that. We'll see how that all plays out, and I will keep everyone updated. Essentially, we have, well, I've just finished all my general relativity lecture notes for the week. Maybe a couple more bits and bobs that can be refined. I'm going to go and ask a couple more questions, but the lecturer for that, absolutely wicked. Christopher Cousins. I think it's Cousins. It's not spelled like cousins, right? There is a Z in this, so I think I'm pronouncing that right. He's a super sound bloke. So basically, you know, I was in GR and I was asking a lot of questions that, you know, no question's a dumb question, but I went in with a lot of questions that, relative to what I think everyone else knew, seemed like a you don't know much kind of thing. But it's literally the case that some people have literally, the majority of them, I think, have actually done a introductory general relativity course. Me, myself, I have not looked at that one bit whatsoever. So I go in and I'm like, okay, let's see how this all goes on. So I'm kind of learning. Everything's quite new to me, right? This is not like week one. This is just stuff that everyone kind of knows. I know like the notation. I appreciate some stuff here and there. This wasn't actually general relativity. It's still more special relativity, but just some things are ever so different to me, right? So essentially, I was asking a lot of questions at the end. I don't know, like just some stuff wasn't clicking. That's fine. Like I have no issue. Not everything's always going to click. And if it does, credit to you, you are operating on a far better wavelength than myself. And I would love some tips and tricks, bro. But that's just not me. And sometimes days like today, you just feel like nothing's really clicking. So, you know, I just stood by at the end, asked him a couple questions. He was actually a super, super nice guy. So essentially, you know, I was asking him some questions. We went upstairs in the maths building, which you guys would have seen and everything. So we sit down and we just start chatting for like 30 odd minutes or something. So, you know, he was asking me about, you know, just more than the course. We started talking about this, like what I did for my undergrad, what modules I'm excited for, and I was just asking him for advice, and he was very, very kind enough to give me a really good layout. So it's, you know, it's kind of lectures like that really make you, they can really kind of shift which kind of path you go down, because I could fully enjoy something like quantum fields more, but if I have a really bad lecturer, I could be very inclined to go down a route of like general relativity. This could be said for like anything. Let's say, I don't know, let's pick law, for example, because, you know, that's a big one for some people. I don't know much about it, but let's say you have something like, I don't know, medical law. That could genuinely be your passion. But if you have a lecturer that just makes you realize that medical law is more painful than actually doing medical law, you might just want to go, oh, that's it, I'm just going to sell out and go and do corporate kind of thing. And that could not be your passion. You could genuinely get into law, not just for the money and because like you want to go, yeah, I'm here to really just help people out. But at the end of the day, like lecturers, I genuinely think are underrated with how much influence they have in terms of pushing you down a certain path. But you know, I could go on for ages about that and why I feel I've been lucky to have some great lecturers in my life and everything to really, you know, guide me down the right path and everything. But story for another day, I guess. But yeah, so first 2 days done. Really have enjoyed that. Really, really class. Can't say too much more about it. Yeah, it's just been good. I hope everyone's enjoyed like seeing what it's like. I think I've shown more about like the scenery of Oxford and everything. And in terms of, I've given a breakdown of the modules and everything. So, you know, I think the only thing that this video lacked was some shifting of steel, but trust me, we'll get right back to it. We'll get right back to it. Today was a rest day, the Tuesday, so, you know, nature of the beast. I also don't want the videos to go to like 40 minutes. If people do enjoy them, bro, I will make them 40 minutes an hour. God, I'll start joining Marvel and all these other movie creators on these 3-hour things. So, you know, you guys will dictate how this goes and everything. So far I'm just kind of sticking to this 15-20 minute range. I waffle enough nonsense that it will probably consistently land up near the 20 and no less. But you know, if that's where it needs to be, that's where it'll be, kind of thing. So not much more to say or report on, but hope you guys enjoyed. All I'm gonna go with is a hoorah.